Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and hello everyone to my lecturer, my fellow friend, and all of you that watching this video. So first of all, my name is Khairul Wasid bin Ali with making number 1616471. So today I want to present to you about the presentation about the my FYP entitled "The Study on the Quality of Imaging Tape of General X-ray in Laboratory of Department of Diagnostic Imaging and Radiotherapy (DDIR) at International Islamic University, Malaysia (Iium). So we move to this presentation have a part where there is a problem statement, objective, literature review, methodology, result and discussion, limitation, future research, and conclusion. So first we move to the problem statement. So the problem statement for my research is where the degradation of the image quality because of the repetition use of the imaging tape. So the McKenzie 2009 wrote on their article about the existence of many artifacts in computed radiography (CR) images have previously have been documented. So in my research, I want to know the performance of the imaging tape because of this computed radiography can be used in multiple times. So the significance of the study is this study helped to evaluate the quality of imaging tape in the radiography laboratory of the Department of Diagnostic Imaging and Radiotherapy to produce the radiographic image. So we move to the objective where the general objective of my research is to investigate the quality of imaging tape of general X-ray in laboratory of Department of Diagnostic Imaging and Radiotherapy (DDIR) at IIUM. So my specific objective for the first one is to calculate the degradation of the image quality based on the calculation of the optical density produced by the imaging tape in laboratory of DDIR. So the second specific objective is to compare the quality of every imaging plate in laboratory DDIR based on the size of the imaging plate and the number times the imaging plate has been used. So move to the literature review. There is some literature that I found my reference. So the Stefano Rivetto et al. 2010 mentioned that the effect explored by the CR system, computed radiography system, is known as the laser stimulated luminescence, where the radiographic imaging process starts when a storage phosphor imaging tape is exposed and trap the electron from the X-ray radiation and the luminescence from the plate photostimulable luminescence phosphor detect for the reading step, and then imaging tape will undergo erasure process to extract all the remaining trapped electron and the imaging plate once again ready be exposed. So this CR system can be used multiple times where the laser stimulated luminescence store the electron, and the electron can be read by the reader, and the imaging tape will be empty and can be exposed again. So second, Mohammed and 2014 wrote in his book titled Radiographic Image Evaluation defined the optical density, where my research focused on as the logarithm of the opacity of a given area within the film, measured as the log of the ratio of the intensity of transmitted light to the incident light. It is a dimensionless quantity. So Ddir et al. 2015 used extract portable transmission estimator and an imaging software that is ImageJ to read the analyze the data. In my research, I use the imaging software that is ImageJ to calculate the optical density on the radiographic image, but not use the decimeter, where then centimeter need the the film of the radiographic image. So Laura LeBrun 2015 wrote in his article about the imaging plate can be damaged over time due to the artifact, dirt, dust, gears, and debris from the reader. To produce a high-quality image, the electronic component need to work in harmony, while the non-electronic components, such as cassette and imaging tape, may be the greater source of the artifact. So, I focus on the performance of the imaging plate in producing the radiographic image. So for the longest one in my literature review is the Hammerstorm et al. 2006 wrote research about the investigation of the image artifact caused by the premature wear of the cassettes and imaging plate by the comparing the three different bands of the cassette. As the result, the cassette with the high number of time used for the processing and the radiographic image having more physical damage and also have high chance to produce image artifact. So my my research compare the performance of the imaging plate to produce the radiographic image and compare it with the number of the imaging plate has been used uh, compare with the number of the imaging plate has been used. We compare the optical density reading between them. So next we move to the methodology where the study venue is at the Radiography Laboratory of Ddir at the Kuliah of Allied Health Sciences at the International Islamic University Malaysia Iium. So my material and equipment is X-ray unit, computer radiography image receptor, acrylic cylinder, steel ring, plastic ruler, imager software version 1.52a, and airspace software version 225 for Windows to analyze the data. So this is my flow of study. The the first is experiment setup where we need a mapping of the acrylic cylinder. So as you can see in the picture here, this is the mapping of the acrylic cylinder where we put the acrylic and the steel ring at the center of the imaging plate. So the mapping is to make sure the performance the uniform placement of the acrylic cylinder and the steel ring. So after the acrylic cylinder have been placed in their own place, the imaging plate has been exposed with the X-ray radiation with the SID 100 centimeter with the 60 kbp and 5 ms. So after that, we collect the data by saving the radiography image in JPEG image, and the derivative image, uh, uh, the, the the image have been analyzed using the image to calculate the optical density to to analyze the analytic data. We use the SPSS software. So as for the result and the discussion, where for the first one, I want to show you about the graph optical density reading uh, uh, with the position of as you can see, the reading of the optical density and the position on the respective position. As you can see here, the graph is as you can see the graph is uniform, but there are two cases that have a little bit different reading. This is version one, the imaging plate that with the code V133C and V171C. So this cassette is with the size of 2430 centimeter. So my next move is to compare the optical density reading with the imaging plate size. So next use the experiences to make a one-way between group ANOVA test where the two variable is the optical density reading and the size of the imaging plate. Because of the central limit theorem CLT is not met, we need to use the Kruskal-Wallis test where the result of the Kruskal-Wallis test is the significant or the p-value is we got is 0.768, where it's more than 0.05 that fall under non-rejection. So we fail to reject the null hypothesis where it resulting where there is no significant difference between the optical density and the size of the imaging plate. So as the discussion within the scale of 0.05 to 3.05 OD that available in the radiography image, the smaller the value means the brighter the degree of the overall thickening on the radiography image, where the steel ring have the lowest reading of the optical density where it block or absorb the acceleration to reach the imaging plate. So, Mohagoro et al. 2011 mentioned in the article about the difference of the mean-low contrast score between the imaging system were statistically significant for the alpha and Kodak CR 850A at 95% confidence level, P 0.009, and for Kodak CR system P 0.006. But the difference is because of uh, the the alpha and the Kodak have different age in operation, so the resulting the significant contrast. But all the imaging plate available on the radiography they have the same age. That is all the imaging plate have been used from the 2012 all the cassette. So this is the total number of times imaging plate have been used. So we can see the 18 times 24 cm have the lowest reading of the number of times used, where the 25 and 43 have the highest number of times imaging plate has been used. So the limitation of this research is that there's no new imaging plate. There has not been used to record the reading of the optical density, where the performance of the imaging plate at the peak. So I cannot uh, I cannot compare the new one and the used one. So the second limitation is all imaging plate available on the laboratory have low number of time imaging plate have been used because of the imaging plate only used for the experimental and educational process for the student. So my future research is uh, I think we can analyze the performance by using the different thickness of the acrylic cylinder where we make a like a step wedge. But my research only use one thickness of the acrylic cylinder. Second, uh, the research can be done by using other properties of radiographic image. As we know, there is many. For example, contrast, density, resolution, and distortion. So, finally, my conclusion is the performance of the all imaging plate available on the laboratory are same, where the radiographic image produced from the imaging plate does not have the significant difference in the optical density reading. So next, the optical density reading, or we call the degree of overall darkening, are the one of the main characteristic in the radiographic image. Beside the contrast, resolution, and distortion. So here my reference. Okay, that's all from me. Thank you. I hope this video help you to find another perspective uh, to help in the radiographic field, radiographic field.